Hello, this is Dr. Lauer. I'm going to work through the test 2 review for Math 117 that's posted on Desmos. You should have received the link. I want to also have the calculator open, the graphing calculator, so you want to go to desmo.com calculator and get the graphing calculator open for some of the problems. You should plan to have this set up for the test. So when you go to the review, you want to type your last name, comma, and your first name. Hit go, and then you're going to get into the review. The first page tells you what you should know for the test. The second page has some problems already. So what is market equilibrium? That's when supply equals demand. List the structures on a graph of a function that cause the limit to fail. Those would be jumps, vertical asymptotes, and heavy oscillation, which you won't see in the test, but part of the test is to give that answer. So if all the limits exist, where could the function still be discontinuous? And that's at holes. And holes are removable discontinuities. What is the derivative? It is the slope of the tangent line to the curve. You may have to answer these on paper, questions like these. So you may have a sheet in Desmos like these where you're answering them on paper. And then if you hit show answers, it's going to show you your answers. You need to know the formulas for your derivatives. In particular, the product and the quotient rule are here. You'll have to use those at least once on the test, each of them. Choose the letter of the linear equation. Well, I need one y and one x. Y and x, so that's the one. So if I solve this for y, I have y is equal to, I need m times x plus b. So my slope here, if I move the x to the other side, I'm going to end up with a positive 6/4 rather, which is 3/2. 3/2 x. And then if I move the 7, that gives me a 7 divided by 6 will give me a negative 7/6 minus 7 divided by 6. If I submit the correct answer, it's there, and show answer will be like this. Now, I'm not going to work through all of the answers on the test, but I am going to tell you about how to work through the rest of them. So you should be able to take an equation like this and make it into an equation or line. Be aware that I can't give all of these questions on the test because it's too many for the test, but you will have ones very similar to the ones that are on this review. The next one says to determine whether the given function is polynomial, rational, or other. I'm going to put cap locks on and just show you what the first one looks like. This one should be a polynomial because it's x squared minus x minus 1, and the degree is 2. Down here, note that x to the 8th times 3 is going to give me a degree of 24. R times r to the 5th will give me a degree of 6. And then the other ones, you have to decide whether they're rational or other. A manufacturer has a monthly fixed cost and a production cost. So here I'm going to need the C of x and R of x, and I will on the test. So I should write C of x equals, then we have a fixed cost and a variable cost. So it's 34,000 plus 9x. The revenue function equals the price times the demand, so the demand 11 times the quantity, 11x. Price times quantity always. Sometimes you'll have a price function, so you'll have to multiply more than just this. So that gives me a check. My profit function, I can actually take this revenue copy and paste it, Control V, minus, put parentheses, I need the cost function, and sometimes typing it would be just faster, but I wanted to show you that you actually can do Control C, Control V, and you end up with your profit function. Now to get the profit here, I could either go to my graphing calculator or use my scientific calculator. So here with my scientific, just paste that in, and then I want P of 7, and that should be 7,000 units, 7,000. There's a typo there, and I can't fix it. And then P of 110,000. P of 110,000. So I can see this is a negative 20,000. I can copy and paste it from here. Remember that we went to 3 decimal places. And we end up with the correct units. The next one says gift cards have increased in popularity, and here is the formula for it. What were the sales of gift cards in 2003? This really is, open up your calculator. So we're going to copy this. You can put it over here on the graphing one too if you'd rather. That we need S of 2003 corresponds, well 0 is 2003, so I guess it'd be S of 0. I didn't really need to do S of 0. But I get 47.4. Notice there's a fraction button here. You wouldn't want this in fractions. But I type 47.4. And then what were the sales of gift cards in 2008? That would be S of 3. 8 would be plus 5. So it would be S of 5. And I get 103.395. 103.395. 3 decimal places for the test. The weekly demand and supply functions are given here. So this really is graph the supply and demand. I won't put these down the test, so you'll have to put those yourself. So you're going to graph the supply and demand. So I have P equals for the second one. And then I need to know what happens here. So I'm going to replace the question mark here with the equilibrium price. I will have these on the test, so I won't give you anything else, but I will have this, price and quantity. So I'm going to have to drag this down to see what it is. If I just touch one of these, it gives me the intersection point, which is where the supply equals demand. That's the equilibrium. So it's 422 and 4522. And I can touch the point so that it stays, but it only stayed for a second. 422, 422, 4522. So this is 4522, that's the price, and the quantity is 4.22. Check that one more time. Now it says that P is measured in dollars and X is measured in units of 100, so I actually want this times 100. So that's what I'd want, is 422. So make sure you're reading the units. So I also need to write a sentence stating the production recommendation. So they should, and really you should type like a quote in here. Up here at the plus, you can enter, you're wanting to put a note in, but you could just put a quote in here and it would do it. They should make 422 units at $45.22 each. This will also be stated on extra paper for the test. We're going to do the same thing here, copy and paste them in. We have a graph. If I zoom in, zoom out, and move it down some, I might be able to see this a little better. So I can see that my supply and demand are 54 and 706. So I'm going to sell 54 at $706. So I'm selling 54 at $706. So P is the Y value and X is the X value here. So I want to sentence again. They should, and I forgot the quote again, quote, they should produce 54 units at $706 each. And here we actually know what these are. These are lamps. I think we knew on the last one too. These were tenths, so I really should have put tenths. 422 tenths. It's pretty inexpensive tenths. This one says, consider the supply equation. Here it is. Determine the price at which the supplier will make 1,200 units of the commodity available in the market. So here, I can just type my formula here. I could put it over in the graphing calculator, but I have this one available right here already. In order to do this, I need function notation. So what I want is P of 1,200. So this is 1.7280000. Now see, I've got, this just looks strange. So let's go back and look. It says X is the quantity supplied in units of 1,000. So this should be 1.2. And that gives me $16.93. And I'm going to write to 3 decimals, 16.928. Use the graph to evaluate. List all the values of X where it's discontinuous. Discontinuous holes, jumps, vertical asymptotes, and heavy oscillation, which you will not see on the test. So here I can just type, I want to know why, so I'm going to put holes, jumps, and vertical asymptotes. So I have a hole at -5, and a hole means that it's the graph is going straight through it and there's just a hole sitting there. This is not an old hole, this is an endpoint where there's a jump. This is a hole, so I have holes at -5 and 0. I have one jump. I have a jump and a really large jump, which is called a vertical asymptote. It's an infinite jump, some people would say. So a jump I have at -3. So it's the X values where those things occur on the graph, and the vertical asymptote is at 2. Where they're removable, well, those are the same to the holes, so that'd be -5 and 0. You're not going to see answers here, I don't think. Oh yeah, I do. So I can show them my answers, and you can see I have the exact same answers here. Evaluate the following. F of -6 would be 3. F of -5 is 2, and so on. So just ask me if you've got a question. Oh, it should be -2. Ask me if you've got a question about any of these, but I'm going to let you continue with those on your own. Evaluate the limits. So the limit, the whole limit with no plus or minus on the back, no left or right side limits. This is a whole limit. There's no plus or minus to the right. So this is at -5. The whole limit at -5 exists. There's a hole there, and it'd be, if I could plug that hole, what that hole is. So that the function value there is. So it would be 3 is what would plug the hole. At -3, we have a jump. So to the left it's one value, to the right it's another value, and at a jump the whole limit doesn't exist. So because I have a jump here, this one does not exist. D&E. But to the left, it's 3, and to the right, it's 4. So to the left, getting on the graph and traveling there, I got a 3. To the right, I traveled a 4. Because 3 and 4 are not the same, the whole limit cannot exist. So there's a few ways to look at these. At 0, we really don't have a problem here. All I need to do is plug the hole. There's not a, it's a discontinuity, but there's not a problem for limits. So this would be at 1, 1, and 1. At 2, we have an infinite limit here. So this, the best answer would be infinity. Spelling it correctly would be helpful. And you can see it says to write infinity or does not exist where applicable. I could copy and paste this because the next one's also going to be some kind of infinity. But to the right, see, it's going down. So to the right, it's going down, so this would be a negative infinity. The limit as x goes to 2 can't exist. For one thing, I couldn't even put infinity here because these are two different ones. There's a big gap in the graph. The limit doesn't exist. At 4, there is no problem. So I'd say that's what, maybe -0.3? -0.3. we want to find the exact values wherever possible for these limits. So if you're having trouble with these limits, what you want to do is copy and paste these onto the graph. Get rid of these. And I can see I'm looking for the limit at negative infinity. So it's saying what happens to this graph, and it looks like it keeps going up and up and up and up. So this would be a positive infinity. There is not a limit, so technically you could write does not exist. And you get a check for that also. But the best answer is positive infinity. Should get 2 checks for that one. The limit as x goes to negative 25 of pi. This says as x is doing something, what's pi doing? And pi is always pi. Now I could put in here, just like I did before, I could put pi and graph it. This would be y equals pi. You can see it's an equation across here with the value of pi. Do not give me a decimal approximation for this. Make sure that you're putting in the exact value when you're doing these limits on the test. The next one, I want to know what's happening at as x goes to 1. So x equals 1. And I can see that the graph right here gives me a negative 0.7. For the infinite limits, I'll do one of these and then I'll let you continue with the rest. Control C. For the infinite limits, Control V. This says the limit as x goes to infinity for this graph. So I'm going to positive infinity this way, and it looks like it levels off and it's going to 0. It never touches 0, it approaches 0. So as x approaches infinity, whatever that means, can't get there. As we get bigger and bigger, what happens to the y values? They get smaller and smaller, closer to 0. So you continue with all of these and do exactly the same as what we're doing here on these previous ones. Use the graphing calculator to find the relevant derivatives and answer the questions carefully. So let's put these in. And I really don't have to use a graphing calculator because I know what the derivative here is. So find an equation of the tangent line. Well, the derivative should be y equals 4x minus 3. Right? So there's the derivative. But I could have also done dy dx of y. And I basically need, if I'm going to do these on a calculator, something like this. And I'm going to call this my d of x. So one of these needs to be a f of x. So this y I have here is actually a derivative. Now it doesn't like the d. It doesn't like the y. So there gives me the derivative. So I'm looking for a particular derivative, the derivative of x. So that would be d at negative 3. And that gives me negative 15. So the equation of the line is y equals 15. Let's check that again. Negative 15. Negative 15 of x plus 3, because it's x minus x1. And then I need to know what the y value is. Well, f of x is my y function, so f at negative 3 is what I need. And that gives me 19. So this would be plus 19. So I want it in this form. So y minus 19 gives me the correct form. So I'm expecting you to leave it in the point slope form just like this. I didn't ask you to solve for y, and I wanted you to see what it looked like. It looked a little wonky. Find an equation of the tangent line to the graph. So we do the exact same thing. So now I'm putting this one in. Don't really need the y here. And I need it evaluated at 4. So I have my derivative, and I have my function value. So I can type in the same thing, y minus the function value was 6 equals m, which is 5.25. And if you wanted to, you could convert this to a fraction, 21/4 times x minus 4. And we're done. The next one just asks for the rate of change, which the rate of change is another way of saying what's the slope at 6. So we want the slope at 6. We don't even need the function value of this function, x squared minus 3x. And actually we had most of it there. So the derivative is 9. But I actually need to write the rate of change is f prime of 6 equals 9. Now this answer is wrong, so you're going to see it display incorrectly. That was unintentional. So the next one gives you a graph to sketch. So here is the World Wildlife Fund, and we have this graph here. So 0 is 1970. We want to know what the price was in 1972 and 1993. So I want to sketch the graph. So I need to type this into Desmos. So I'll need f of, I'm going to make it x because the x's work better in Desmos, equals, and you're pretty much doing the same thing here with the braces and everything. So brace of, I put the restriction first. 0 is less than or equal to, x is less than or equal to 8. And I put a colon and then the function, 8.37x plus 7.44, comma, and then I do the same thing for the other one. 8 is less than x is less than or equal to 30, colon, and we want that at 2.84 x plus 51.68. So we end up with this graph here. It doesn't give us endpoints. We'd have to put those in. But this is fine because what I want is a sketch of the graph, so I need to see that you could put it in correctly. And then what was the price of ivory at the beginning of 1972? Well, 0 corresponds to 1970, so f of 2 would give me 1972. That's 24.18. Then at 1993, that would be f of 1970. 1993 would be 23, right? F of 23. So we get 117. So we could actually put that point on the graph, but it's not necessary. These, you'll probably have to write these answers on paper, but you'll be given the sheet in here to look at for the test. For the next one, we want to find the derivatives of each one of these things. So sometimes you have to rewrite them first. So the derivative of a constant, this is a constant. There aren't any x's in here. The derivative is 0. For this one, I need to rewrite it first. So let me write this as x to the negative 2 divided by 3 minus x 2 times x to the negative 1 divided by 2. So a cube root is a 1/3 power, but we also have an x squared, so that's to the 2/3, and that shouldn't be negative, that should be positive. This is in the numerator. This one should be negative because it's in the denominator, but it's also a 1/2 power. If there's not a number here at the root sign, that means the number is 2. Now what I want is the derivative. So I'm going to need f prime. That's just the single quote beside the inner key is equal to, and I'm going to take the derivative. This would be 2 divided by 3. X to the negative 1 would be negative 1/3, and that's a 1/3 there. It's kind of hard to see. Now you can see it. Minus x to the, this was a negative 1/2, so it would be negative 1/2 times 2 gives me a positive 1. So I just need a plus. 1x to the negative 3/2. And that's because negative 1/2 minus 1 is negative 3/2. So I changed this to y prime because it says y prime, so we'll see if that answer works correctly. Now you're going to do the same thing all the way down the page, rewrite. So you can see this one needs a rewrite. This one needs a rewrite. This one is a quotient rule, and this one is a quotient rule. The derivative of pi again, is a constant. Now if you hit show answers here, you'll be able to see the answers. So you can see what you should have written for your derivative, and this says y prime equals. So the y prime was correct here. So you're not getting check marks here, but you are able to check to see that you've done it. You can also hide them again, so you can work on the derivatives again. The next problem asks for the actual cost, the marginal cost, and the marginal cost at a particular value. So this one would be best work in the graphing calculator because the scientific calculator doesn't have the functionality for the derivatives. So you're not going to see derivatives anywhere here. So I'll copy this into the calculator over here. And what I'll find is that it doesn't like the comma. So notice it's giving me a warning here. Points are written like this. So the comma, they're expecting a point. So it gives you a strange warning, but now I've got my c of x in there. In order to do my derivative, I might want to stretch this out so I can see this a little better. My c prime of x, because I'm going to need to write this, c prime of x is equal to, I've got 3 times 0.0002, so that's 0.0006x to the second power. So I'll expect you to be able to take these derivatives like this, minus 0.04, and you could put 0.04 or 0.08 here, 0.08x plus 27, and the derivative of 3,000, of course, is 0. So there's c prime of x, and it didn't have any problems with that. So it's asked me for the actual cost between the 201st and the 200th. So that's actually c of 201 minus c of 200. So this would be the cost of producing the 201st unit. The total cost of the 201st minus the total cost of 200 gives me just that one unit. So here's my answer of 35.08 to 3 decimal places. It would give me 35.08. I could submit that and I got it right. So the next one is the marginal cost function, and I've got it right here, so I can just copy and paste. I needed it anyway. Oh, it didn't like that. So here I'm expecting exact strings. So to get this to give you a check mark here, you're going to need the 0.08, and I get a check. So this is really picky in Desmos. I'd have to check it differently to get a better answer than this. The marginal cost when x is 200 is c prime of 200, which is 35. So I need c prime of 200 equals 35. So that's what I'm expecting to see on your test. So now I've got those correct. I could also show the answers here, and they're showing. They will not show on the test. These I'd have to write on paper. So you'll see the problem and you'll need to write it on paper. You can hide the answers too so you can play with it again. So the next problem is revenue. I need the revenue, the marginal, that means take the derivative. And here it says once you have that derivative, put in 4,000. Notice there's a comma here, so be careful with that comma. So the revenue function is price times quantity, so I'm going to multiply this price times x, so I'll get negative 0.03x squared plus 700x. And then I'll take the derivative, and then I'll put 4,000 in, just like we did with the cost here. The next problem is a total cost problem again. We want the marginal, so again we're going to have a c prime equals, and then I want the rate of change. That's the derivative, put in 10. I can show my answers. I want a bacteria growing here, so P is f of t, which is this equation. So here's my equation. This first asks for the population at t equals 6 minutes. Well, this is the population, so I'm just putting 6 minutes in. So that would be like c of 6. where we have over here, only you're going to put F here. So I could just copy and paste this. Clear that out and put my graph in, and then I'll need to go and do f of 6. So it's easy enough to get answers to these pretty quickly. You could also do f of 6 here, doing the same thing in this calculator, and finding the rate of population growth. That means take the derivative, which is easy enough to take at 6x plus 2, and put that in here. So you have a couple of ways to do these problems correctly with the Desmo calculator. The next problem asks us for the instantaneous rate of change. So that means the derivative. So we want f prime is negative 0.2x minus 1. And we'll put in 4200. Well, that's not quite right because x is measured in units of 1,000. So if we want the quantity demanded to be 4200, we'd have to put in 4.2. Your answers are there. You can check them. Good luck on the test.